Writing ionic compounds. In this example problem, it says which of the following is the correct formula for sodium oxide. So in this problem, we first have to know what we're talking about and how to write ionic compounds. So sodium oxide is the formula we're looking for. Whenever the formula is given, it shows us the cation and the anion. So here, usually the cation is written first, so we know that Na is going to be the positive charge. And we know that oxide, which stands for oxygen, but notice that when it's in an ionic compound, it ends with IDE. And if it's a polyatomic ion, it's actually going to be the name of that polyatomic ion, whether it be sulfate or nitrate or some other polyatomic ion. So this stands for oxygen. So we know that we're working with two different elements here. So there are going to be two ways we're going to discuss how to write ionic compounds. The first is to just write out their charges. Na plus is the step for both of them. Na plus and 2 negative. That is the most common cation for Na and the most common anion for oxygen. So what we notice here is that Na is saying that it's going to transfer 1 electron, but oxygen wants to get 2 negative electrons. So how does that happen when we only have sodium and oxygen? What this means is that whenever we have an ionic compound, the charges of that ionic compound, that whole ionic compound is going to be neutral. Charges are going to be neutral. So we want to make sure that there's not a net positive or a net negative charge on this ionic compound. So we're going to actually try to figure out how much of each we need. So for this particular problem, we need actually 2 NAs to donate or transfer their electrons to oxygen. So they're donating 2 valence electrons transferred. Okay, and I'm going to write E negative for electron, transferred. And then 2 valence electrons received. And that makes sense because oxygen 2 negative, it wants those two valence electrons. So this is going to be how many Na atoms do you see, let's say, or Na ions do you see? 1, 2. So there's actually Na 2. So that means there's 2 Nas in that compound and only 1 oxygen. 1 oxygen. So this is the formula for this ionic compound. Let's learn the second way, which is going to help us with charges just like this, ones that are uneven. Because it would be very easy if, let's say, this was 1, we would only need 1 Na and 1 of whatever the other element was because those charges are 1 to 1. However, when we have something that the charges are not 1 to 1, so let's say something like Na and oxygen, we're going to do Na plus and 2 negative. Again, write out the charges so you make sure that you know what they are. And what we're going to do is called the X rule. We're going to move this number, just the number, not the charge, because we're just using a ratio to tell us how much NAs we need to oxygens do we need to make sure that the charges are neutral. So I'm going to move this 2 down here. So Na 2, so I just move that number 2 to the bottom and then put that positive and put that on the bottom here, so that's oxygen 1, because whenever I put that positive, it means there's only 1 electron transferred. So when we write it like this, remember that we only write Na2O. We don't write the 1 here because it's assumed when you write an element that there's 1 of them there. So this, again, shows us the same thing that we got here by just thinking about how many atoms we need to make sure that we balance out the charges. We got the same answer using the X rule. So that's Na2+. Now for an exception, just to make sure that we understand, Mg, let's take this example, even though we have the answer for this question, which is E. let's make sure we understand the X rule really well. So Mg has a charge of 2 plus, and O has a charge of 2 negative. And I want to mention that when you do the X rule for this, when I transfer the numbers down there, it's going to be Mg2O2. However, that's the wrong ionic compound formula for this ionic compound, because we only really need one Mg to combine with one oxygen so that the equal numbers are transferred and received. Because if this one gives up 2 valence electrons, oxygen can accept 2 valence electrons, and it doesn't need an extra Mg to donate more electrons. So what we do is actually we reduce this, so you would divide these subscripts by 2, or by the number, whatever number they are, and you would get MgO, because you would use the first method more easily to see that there's only one of Mg and one oxygen required so that the charges are neutral.